Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Alpha-tetralone is a bicyclic compound consisting of a benzene ring fused to a cyclohexanone ring. The carbonyl C is equal to O is at position 1 and the aromatic ring carbons are at positions 5, 6, 7, 8, 4A and 8A. Moving on to the next step. The carbonyl group attached at C8A, the ring fusion carbon adjacent to the aromatic ring, acts as a meta-director and deactivator for electrophilic aromatic substitution. The other ring fusion carbon C4 is connected to the aliphatic CH2 chain and acts essentially as an alkyl substituent, which is an ortho-para director. Moving on to the next step. The aromatic ring has two substituents influencing EAS, I. The carbonyl at C8A, meta-director, directs to C6 and C5, meta positions relative to C8A, and 2. The alkylic C4 adjunction, ortho-para director, directs to C6, C8 and C5, ortho and para to C4A. The position C6 is both meta to C8A and ortho to C4A, making it doubly activated and the most favorable position for electrophilic attack. And for the final step, sulfonation at C6 gives the product shown in option B, where the HO3S group is at the 6th position of the aromatic ring, ortho to the C4A ring junction and meta to the C8A carbonyl-bearing ring junction. Option A places SO3H at C8, ortho to C8 a carbonyl is equal to deactivated position, ortho to C4A is equal to activated, but ortho to the electron withdrawing carbonyl carbon makes this less favored than C6. Option C places SO3H at C6 but the structural drawing corresponds to a different regiochemistry. Option D places SO3H at C5, periposition adjacent to CH2, sterically hindered and not the most activated position. Therefore, the correct answer is B. Therefore, the correct answer is option B.